All right, here's part 5, questions H through O. All right, for H, I have 2 times e to the x plus 4 equals 122. When I solve this, I want to isolate the exponential e to the x. In order to do that, I have to move the 4 and the 2. I'm going to start by moving the 4 by subtracting it. I'll get 2 times e to the x equals 118. And then I divide by 2. Now, when I do that, e to the x equals 118. I have the exponential isolated. And in order to solve this exponential, I use its inverse, which is the natural log. I take the natural log of both sides. Remember, natural log of e goes away. It's just 1. And all I have to do is type, I have x equals the natural log of 118. So I'll just find that value, which is 4.771. Hey, hold on, that's not what I got here. Did I do that wrong? Oh, I forgot to divide by 2. That would be my problem. 118 divided by 2 is 59. I apologize. Looking at my answer, and it didn't match. So I take the natural log of 59 in my calculator, which is 4.078, which is exactly what I have over here. There we go. All right, let's look at I. I have 2 to the 3x minus 7 equals 131. This is an exponential equation, so I either have to use common basis or the common logarithm. Here, 2 and 131 do not have a common base, so I'm going to take the common log of both sides. When I do that, 3x minus 7, that exponent comes in front, and I'll take times log of 2 equals log of 131. Before I can deal with the 3x and the minus 7, I have to move all the logs to the same side. So I'm going to divide both sides by log of 2. That'll give me 3x minus 7 equals log of 131 over log of 2. Now to finish solving this, I need to add 7 to both sides. I'm going to do this in one step to save some writing. And then I'm going to divide all of that by 3. So it's very particular here how you type this into your calculator. You're going to first take the logarithms here. You're going to divide log of 131 by log of 2. Now what you're going to do is the next part. You're going to add 7 and enter again, and then divide by 3 and hit enter. So add 7, enter, divide by 3, hit enter, and you get 4.678. And there you are. All right, let's jump over to J. Log base 3 of negative 2x plus 9 equals 4. This is a logarithm to start, so in order to solve it, we turn it into an exponential using the definition here. So I'll take 3 to the 4th equals negative 2x plus 9. All right, 3 to the 4th is 81. So I have to subtract 9 next. 81 minus 9 is 72. And then I just divide 72 by negative 2. And I get negative 36 as my x value. All right, k here. 5 plus 9 to the x plus 1 power over 2 equals 16. This is an exponential function, but I can't decide what to do until I isolate that exponential. So what I'm going to first do is multiply both sides by 2. It'll give me 5 plus 9x to the x plus 1 equals 32. And then subtract 5 from both sides. Now what I have is 9 to the x plus 1 equals 27. Now that I've isolated the exponential, I can decide, do I use a common base or do I take the log? Here, 9 and 27 both have a common base of 3. So I can use common bases if I want, or I can use a logarithm. I'm going to show you common bases. I'm going to rewrite the 9 with a common base of 3. So not 3 squared keep the same exponent, and 27 is 3 cubed. Now I multiply these exponents together, 2 and the x plus 1. And if I want, I can go ahead and jump down to say this is 2x plus 2 equals 3. When I subtract 2, I get 2x equals 1, and divide by 2 here. So x is 1/2. All right, L. Natural log of negative 2x plus 3 equals 7. Now, I've given you a logarithm, so I have to turn it into an exponential in order to solve. Here for this natural log, the base is e. So when I turn this into an exponential, it'll be e to the 7th is negative 2x plus 3. Now, we are going to write this as a decimal, but for now, I want you to leave it as e, and we'll type all of this into our calculator at the end. So what I'm going to have you do next is solve for x. So I subtract 3. So I have e to the 7th minus 3 is negative 2x. And I divide the whole left side by negative 2. I can type that, if I want, just like that, into my calculator. Or I can do it step by step, but I'll do it this way. I'll do e to the 7th, and it's e to the 7th minus 3, all over negative 2. And this is my answer, negative 546.817. Three more for this video. Log of x over 8 equals negative 3. In order to solve this logarithm, I have to turn it into an exponential. The base of this common logarithm is 10. So I use 10 as my base for the exponential. Now let's simplify. 10 to the negative third is 1 over 10 cubed. And 10 cubed is 1,000. So this is 1 over 1,000 equals x over 8. All I have to do is multiply by 8 on both sides. And let's see, what's 8 times 1 over 1,000? 0.008. Or 8 over 1,000 if you want to leave it that way. All right, and n. Before I can decide what to do with this exponential, I need to isolate the exponential. So I'm going to start by dividing by 3. 10 to the x equals 540. Now I have 10 to the x and 540. My bases are 10 and 540. They do not have a common base, so I need to use the inverse of an exponential, which is a logarithm, to solve this. I'm going to use the common log of both sides. And the common log of 10 will really help us out here to make this a faster problem. Just like we know that the natural log of e is 1, we should also know that the common log of 10 is 1. So I can cross that guy off, just like we did with the natural log of e, because that equals 1. So all I have is x equals log of 540, and if I type log of 540 into my calculator, that would be my answer, 2.732. Last one. This one was kind of tricky for some of us in class yesterday. 27 times 3 to the x equals 81 to the 2x. Now, I know we've always talked about isolating the exponential, but the hard part about this is that I can't just divide the 27 away because I have x's on both sides in the exponent. So what I do want you to notice is that each of these numbers has a common base of 3. So I'm going to solve this with common bases. 27 is 3 cubed times 3 to the x, that doesn't change. And 81 is 3 to the 4th to the 2x. Now before we move on, I'm going to rewrite this with exponents. I'm not going to just solve the exponent again. So I have 3 to the, here I'm going to add those exponents up. 3 plus x equals 3, here I do power to a power, to the 8x. Now that both sides have the same base of 3, I can take their exponents, set them equal, and solve for x. So I'll have 3 equals 7x and divide by 7. And there you go. Alright, if you have questions on any of the solving ones or why I used a certain method, please ask me or Mr. Brown.